such as this one. And so in this video I want to show you how to solve a system of equations both in 2 variables and in 3 variables using Cramer's rule. So this is what we are going to do in this video. So to get our discussions underway, we are going to follow the steps. Well, so the first step here, we need to write these two equations that we have in a matrix form, right? So we are going to form what we call a matrix of coefficients. So we have 1, 1, 3. You can see I'm just writing the coefficients of the variables that I have in the two equations. So we call this a matrix of coefficients, usually denoted by D. Then I'm going to write what we call the matrix of variables, showing you the variables that you have. So we are dealing with x and y variables. And finally, we write the matrix of constants. So we have 7 and 11. This is the matrix of constants, the matrix of variables, and D is the matrix of coefficients. So what we have to do, the second step, we just need to find the determinant of the matrix of coefficients. So we need to find the determinant of the matrix of coefficients, which is D. So I'm not going to write D, I'll just write 2, 1, 1, and 3, right? Now we know that finding the determinant of this, we use the formula. We need to multiply AD minus BC, right? If you don't know how to find the determinant of a 2 by 2 matrix or 3 by 3 matrix, you can just pause this video, scroll up, you are going to find 1 or 2 videos showing you how to do just that. Okay, so this means we are going to multiply 2 multiplied by 3, and we are going to subtract 1 multiplied by 1, right? And this will give us 6 minus 1, and you are going to get 5, right? So this is the determinant of matrix D, which is the matrix of coefficients. Now the next thing we want to do, we want to calculate the matrix dx. Okay, matrix dx. In case you are wondering what matrix dx is, well, matrix dx, this matrix is formed by substituting the first column of a matrix of coefficients that we have with a matrix of constants. So what I mean is, this matrix of constants that we have is going to substitute the matrix, is going to substitute the first column in the matrix of coefficients that we have. So if we do that, a matrix of coefficient, just a moment. Okay, good. So a matrix of coefficients that we have here is going to be to have its first column substituted by a matrix of constants, and the second column is going to remain the same. Now we need to find the determinant of this matrix, which means we have AD minus BC, right? So we still have dx this side, right? So it's the determinant of matrix dx. That's what we are calculating here. So if we do that, we are going to have 21 minus 11. Now the determinant of matrix dx is going to give us, if you substitute here, we are just going to get 10, right? Good. And the other thing we want to do next is to just calculate the determinant of matrix dy. So just like matrix dx, matrix dy is formed by substituting the second column, which is substituting the y values, the coefficients of the y variables by the matrix of constants. So that means we are going to have, sorry, this is 2, we have 1, then our second column is substituted by matrix of constants. Again, we need to find the determinant here, so we have AD minus BC, right? Now what this means is that we are going to get the determinant of dy to be 22, right, minus 7. Now what this is going to give us is nothing but 15, right? So we're going to get 15. Now how do we find the values of x, y, just x and y? So now we write to say x is equal to matrix, the determinant of matrix dx divided by the determinant of matrix D, which is the matrix of coefficients. So matrix, the determinant of matrix dx was 10, right? That was the value that we calculated, divided by D. Now this gives us x is equal to 2. Now we do the same for y. We have y is equal to dy, right? The determinant of matrix dy divided by the determinant of matrix D, which is a matrix of coefficients. Now the determinant of matrix dy was 15 divided by matrix D, which is our the matrix of coefficients. Now its determinant was 5, right? Was 5. This gives us 3, right? So that means we have x is equal to 2 and y is equal to 3. So this is how we use Cramer's rule to find the values of x and y in a system of a 2 by 2 matrix, or in a system of two variables, that is x and y. Now let us apply the same thing to a 3 by 3 matrix. So again, we just follow the same procedure. So what we want to do here is to write our matrix in remember this is z here and not 2, okay? So this is z. So writing the coefficients, we have 1, we have 3, right? Then we have negative 2. Next we have positive 2, we have negative 2, then we have negative 1, and the third row we have 3, right? 3, we have 1 and negative 1. Good. Then we have a matrix of variables. So this time we have x, we have y and z, right? Now we equate this to a matrix of constants, and the matrix of constants that we have 7, we have negative 3, and we have 10 right there. Okay, now what we want to do here, we need to remember this matrix here is a matrix of coefficients, right? So this is matrix D, and the second thing we want to do is to calculate the determinant of this matrix D, right? So this is what we want to do, to find the determinant of matrix D, right? So again, I'm just going to, okay, let me just copy the same matrix here so that we can use it. Just want you to see clearly what we will be doing. Okay, so just a moment, and here we go. So this is the matrix of coefficients that we have, right? Now to solve this matrix of coefficients, to solve its determinant, there are various ways that you can use, and it doesn't matter which one you use, as long as you do the correct things, you are going to get the same answer. So what usually happens here, like I said, you can pause the video, scroll up so that you can find out what happens here. So what happens here, it's like you cancel your first column and your second column so that you come up with a new matrix, right? And this new matrix that you come up with is, you're going to have that's -2, right? -2, -1, 1, and -1, right? Right. So the second one here, now here there is something that you need to remember, right? We apply the system here, positive, negative, just a moment, positive, negative, positive, negative, positive, negative. So we multiply these signs to these numbers in a matrix. I'm sure when you scroll up and find the video teaching you how to calculate the determinant of a 3 by 3 matrix, you are going to find how this is well explained. Okay, so just do that. So if we do that, we see that the next one, that means if we cancel, right, this matrix, we cancel the second column and the first row, right, we are going to remain with that matrix, right? We're going to remain with, to have that's 2, okay, that's -2. Is it -2? No, that's -3. Just a moment. So that's we have -3 there. So just pause the video, scroll up so that you can find out how this is being done. So we have 3, we have -1 and -1 right here, right? And then we have a positive, and we're supposed to put a positive, but we see that the number where we are meeting this column, again we are cutting now this time the last column and the first row, and if we do that, you can see that we are intersecting at -2, right? So we have -2 right there, open bracket, you have -2, you have 1, you have -1, and right here you have -1. Okay, is that it? Okay, so let's see what we are getting. If we cut this and this, not really, that's not what we are getting. Remember, we have cut just a moment here, we have cut this one and that one, right? So we're remaining with this matrix right here. Okay, sorry about that. This is the matrix we are remaining with right there. So this is what we are going to write. So we have let me also just do this so that you follow it nicely. Okay, all right. So we have, if we do that, we're going to remain with a matrix 2, we have 3, we have -2, and we have 1 positive right there. Okay, now if you solve this, okay, if you solve this using what we are doing in a 2 by 2 matrix, finding the determinant, you are going to find that the first one here, you are going to have 2, right, minus, open your bracket, minus 1, right? Now this you close, then you're going to have -3. If you do the same there, you are going to get that's -2, right? Open bracket, minus 3, right? So what we are doing here, we are multiplying again. We had negative 2 times negative 1, again negative 1 times 1. Okay, again here we do the same, negative 1 times 2, then 3 times negative 1. Again here we have outside, we have negative 2, so we are going to open a bracket, then we have 2 times 1, that will give us, right, 2 minus 3 times negative 2, that will give us negative 6. Okay, good. Now what this is going to give you is nothing but you're going to have 3 minus 3, right? Then you're going to have minus 16, right? So you find that this and this will just give you a 0, and you are going to have negative 16 right there. So this is the determinant of your matrix D right here. Okay, so this is how you solve for the determinant of a 2 by 2 matrix. All right, good. So we proceed there. Now next we need, this is our third step now, right? So here we're going again to write our matrix dx. Okay, now matrix dx, just like in a 2 by 2 matrix, how does this matrix come about? Well, you substitute your first column with by your matrix of constants. So our matrix of constants is 7, negative 3, 10, right? So this is what we have. So we have 7, negative 3, and 10 right there, while the other two columns will remain the same. So we have that. Remember, the x variables in the first column, they have been substituted by the column or the matrix of constants. So we have right that, and also the third column remains the same, right? So this one remains the same. So again, if you are going to solve this just like what we are doing right here, okay, from the previous question, we are solving the determinant of matrix D, which is the matrix of coefficients. You are going to get that's 21, right? You're going to get 21 minus 39, right? Minus 39. Again, you have minus 34, right? Now what this gives you is negative 52, right? You're going to get negative 52. Again, you are going to solve for dy, right? So dy, that means your second column, which involves the coefficients of y variables, is going to be substituted by the matrix of coefficients. So if that happens, the first column will remain the same. So you have 1, 2, 3, right? This was the original. Then you have the second column substituted by 7, negative 3, right? Negative 3 and 10 right there. Then you are going to have your third column remain the same like this, right? Okay, then we have to find the determinant of this matrix dy. Now if you use the same procedure as in the first step, you are going to find that you're going to get okay, let's see this, you are going to get 13, right? So this, you have the same dy, you have the same dy, you have the same matrix of dy. You are going to get that's 13, right? Minus you have 7, then you have minus 58, right? Now if you subtract this, you are going to get negative 52 as well. Okay, so even this one will give you negative 52, right? Now we can now formulate dz matrix dz, and dz now is formed by substituting our third column in a matrix of coefficients by the matrix of constants, right? So this means our first column, our second column, which is 3. Okay, let me just write that one properly. So where we have 3, we have negative 2, we have, now what do we have there? We have 1, and our third column is substituted by 7, right? That's by 7, by negative 3 and 10 right there. Now solving the determinant of this matrix, so using the same procedure, we are going to have the determinant of matrix dz is going to give us negative 17, right? Yes, if you calculate that, you're going to get negative 17. Now negative 87, and you have plus 56, right? Now this will give you nothing but negative 48. Negative 48. So this is what we are getting. Now again, we apply the formulas to solve for x, y, and z. So we have x is going to be dx, which is the determinant of matrix dx, right, divided by the determinant of the matrix of coefficients of a 3-variable matrix or system of equations, which we found dx to be negative 58, right? Dx was negative 52, I mean, not 58, divided by, that was 16, right? Okay, good. So that was, in fact, that was negative 16, right? God, let me just write this properly. So this was negative 16, which will give us nothing but 13, right? If you reduce this, that's 13 over 4, right? Again, we do the same there. We have y is equal to the determinant of matrix dy divided by the determinant of a matrix of coefficients, which we solved, and we found this to be again negative 52 divided by negative 16. This one too is going to, so this is 16, right? This one too is going to give us 13 over 4, right? So that's what we have. Sorry about that. So we proceed, and then we have z. We have dz divided by d. Now our dz was found to be negative 48, right? Divided by that was negative 16, right? Now what this gave us was, if you divide this, you are going to find that negative 16 can go into negative 48 3 times, right? 3 times. So this is how we calculate the values of x, y, and z in a system of equations in three variables using crama's rule.